Amorphous silicon is the non-crystalline form of silicon. It is used as semiconductor material in solar cells and as thin film transistors in LCDs. It is one of the most environmentally friendly photovoltaic technologies since they do not require any toxic heavy metals such as cadmium or lead. Today's session deals with the calculations involving unit cell dimensions. Let us see what are the possible calculations that we can make with the dimensions of the unit cell. First, look at the sentence, density of the metal is the density of the unit cell. Now, how is that possible? Density of any substance is mass per unit volume of that substance, isn't it? Now, what is the density of the unit cell? It will be equal to the mass of the unit cell by volume of the unit cell. Last class we had discussed about the volume of the unit cell. For a cubic unit cell, if A is the edge length, the volume will be A cube. We know that. Now what about the mass of the unit cell? It will be equal to the mass of the constituent particles contained in that unit cell. Because unit cell is not a material object, it is simply a cubical space. So mass of the atoms in the unit cell. So that depends on the number of atoms in the unit cell. And number of atoms in turn depends on the type of the unit cell. Whether it is an FCC unit cell, that is face-centered unit cell, a body-centered unit cell, a simple cubic cell, or even an end-centered unit cell. So here we can take the number of atoms as Z. Let it be any type of unit cell. We can take the number of atoms of the unit cell as Z. And mass of an atom can be taken as small m. Mass of an atom in turn depends on the type of atom, whether it is a copper atom or whether it is a silver atom, like that. Mass of an atom is calculated by this equation, atomic mass by Avogadro number. Atomic mass is otherwise the molar mass of the atom divided by Avogadro number. How much is Avogadro number? 6.022 into 10 raised to 23. So molar mass is the mass of 1 mole. 1 mole means Avogadro number of particles. So in order to get the mass of a single atom, we have to divide the molar mass by Avogadro number. You know all these basic things. Now come to the volume of the unit cell and the mass of the atom. Because we want to find out the density of the unit cell, which will result in finding out the density of the solid, because density of the solid is equal to the density of the unit cell. So we have the volume of the unit cell as A cube. Let the edge length be A of this unit cell. You know how to calculate the mass of an atom. We have marked Z as the number of atoms. So density of the atom is calculated by the formula mass of the unit cell by volume of the unit cell. So substituting that, in this particular box we have Z into capital M, where M is the molar mass of the substance, divided by volume A cube and Avogadro number Na. So we have substituted the mass of an atom by this equation, atomic mass by Avogadro number, and that is how we got this equation, density is equal to Z into M by A cube Na, where Z is the number of atom, M is the molar mass or the atomic mass of the substance, mostly a metal, and A is the edge length of the unit cell and Na is the Avogadro number. Now we have a formula to calculate the density of a solid, which is equal to Zn by A cube Na. Now let us learn to calculate any one of these parameters if one of it is unknown using this formula. So we have a problem here. I'm going to read the problem first. Copper crystallizes in FCC unit cell with edge length 3.608 into 10 raised to minus 8 centimeter. Copper is determined to have a density of 8.92 gram per centimeter cube. Calculate the atomic mass of copper. So we are given 4 parameters here. We are going to find out the fifth one, that is the atomic mass of copper. All other parameters are given to us. Copper crystallizes in FCC unit cell. So from that little bit of information, FCC unit cell, we know that the number of particles in this particular unit cell will be 4. So Ez is equal to 4. The second information, cell edge length 3.608 into 10 raised to minus 8 centimeter. So A is equal to 3.608 into 10 raised to minus 8 centimeter. Copper is determined to have a density of 8.92 gram per centimeter. Density is given here, 8.92 gram per cc centimeter cube. And Avogadro number is known to you. Now we are going to calculate this particular quantity, that is the molar mass or atomic mass of the metal. Now once again, the equation is here, D is equal to Zn by A cube Na. Now let us substitute the values in the equation. So D equal to 8.92 gram per cc is equal to 4 into m, the molar mass, divided by edge length A 3.608 into 10 raised to minus 8 the whole cube into 6.022 into 10 raised to 23 Avogadro number. Now we can rearrange this equation to find out m. So m is equal to 8.92 gram per cc into 3.608 into 10 raised to minus 8 the whole cube into Avogadro number divided by 4. Now you may use your calculators. You'll get the answer as 63.1 gram per mole. So the atomic mass of copper, you'll get the result as 63.1 gram, which is equivalent to 63.1 U, that is the unified mass. Hope you understood this problem. It is very simple. The only thing is that you need to know the formula. D is equal to Zn by A cube Na. If you know all the 4 parameters, the 1/5 unknown parameter can be calculated. We'll do one more problem. So I'm reading the second problem. Silver forms CCP lattice. The edge length of the unit cell is 408.6 picometer. Calculate the density of silver. Atomic mass of silver is given as 107.9 unified mass. Now let us take a look at the informations given here. Silver forms CCP lattice. CCP lattice has FCC unit cell. So what about Z? Z will be equal to 4. The edge length of the unit cell is 408.6 picometer. That is, A is equal to 408.6 picometer. Calculate the density of silver. So, density is unknown. The atomic mass, capital M, is given to us 107.9 U or gram per mole, and Na we already know 6.022 into 10 raised to 23. So we have this much information. The only unknown quantity is D, the density. So remember the equation, D is equal to Zm by A cube Na. So let us substitute these quantities. Before that, look at this edge length. It is given in picometer. Density can be expressed in gram per centimeter cube or kilogram per meter cube. Since molar mass, the unified mass, can be directly taken as grams, we may use gram per cc. So we can convert this picometer into centimeter first. For that, how much centimeter is 1 picometer? 1 picometer is equal to 10 raised to minus 10 centimeter. You have learned this relationship last year. Hope you remember it. Now 408.6 should be multiplied with this 10 raised to minus 10 to convert it into centimeter. So let us substitute all this in this equation. D is equal to Zm by A cube Na. We'll take the next page. So D is equal to Z is 4 into molar mass 107.9 gram divided by A cube. A cube was, A is 408.6 picometer. We have to convert it into centimeter. 408.6. 408.6 into 10 raised to minus 10 centimeter, the whole cube, into Avogadro number 6.022 into 10 raised to 23. If you calculate, it comes about 10.5 gram per cc or centimeter cube. So this is a direct substitution. Z m picometer converted to centimeter, that is the edge length, and Avogadro number. You get the answer as 10.5 gram per cc as the density of silver. Problems based on this density equation are frequent questions in the examinations. So practice more of such problems and be thorough with it. This is all for today's session. Thank you. Have a nice day.